Hello, I think we're live, but I'm going to let it sit for a bit so that I can see if a couple people will come in, start watching. But for now, just enjoy the ball falling, and I will get to the explanation in a few minutes. Is it showing the program on the screen for you guys? Alright, so basically what I have going on here is I have created a small program that is basically an artificial intelligence. Now, um, what it is so basically the point of having a artificial intelligence like this is that it can be given a task and it will go through a process of uh, of trying different options until it optimizes a solution and is able to perform that task. The task that is being performed right now, as you can see, or when it is running, is there's a red ball that is falling down the screen, and the goal of the task is for the blue string of balls to catch the red ball and stop it from reaching the bottom of the screen. If it does so successfully for a long enough period of time, the ball resets, goes to a different position, and the program keeps going. But if the red ball reaches the bottom, that running of the program is terminated, and the program is assigned a score, as you can see in the top right there in the black box. So I can see that it's conking out here, but that's just a minor problem I've been coming into. But other than that, I'll get into how this program works and what I've been working on. So basically what I've been working on is it started out as a genetic artificial intelligence, and basically what a genetic artificial intelligence is is an evolutionary type process, much like how evolution has a system where only the fit survive. This program tries many different options, and when it sees something that scores higher, it then takes that program and uses it as a basis for the next generation of programs. And you'll see at the bottom of this string of numbers, it will give a report on the current generation, and that basically says how well it's doing right now and how long it's been stuck on the one stage, but I'll get to that later. So basically what it does is it has a string of options, and the options that it has are different points in the decision-making process of whether or not it should be moving up, to the side, down, and whatever. And the program randomly assigns all of these options. So it says it gives a random assignment to whether or not it wants the blue balls to go up or down or whatnot in a different situation. And when it sees that random assignment doing well, it associates that as a good trait, much like how if in evolution, if something were to evolve to have some trait that made it superior to its competition, then it would tend to have a higher potential to reproduce, so then it will spread that trait throughout the next few generations. The way that this program does that is by assigning the next generation's traits based off of the two highest scoring programs. And so first off, I'll explain how something can score. In this program, the way something scores is based off of a fitness test, which the fitness test for this program is when the red ball is close to the ends of the string of blue balls. The score starts going up, and the score goes up by more if it is closer to the ends of the string. Then when the ball resets, the score stops going up, but if the string were to chase and move over to re-catch the ball, then it would start going up again, and the score would go up even more. And also, there is a multiplication factor for if the program catches the red ball more than once. For each time the ball is caught, the score is multiplied to make it a substantial amount higher than if the ball is only caught once. So, with that being said, so that is the way the program tests the different options for the different traits, and the way it assigns the new traits to the new generation is by randomly choosing a trait from either of the parent programs. So let's say one program said the string should go to the right in a certain situation, and one program said the string should go down in a certain situation, um, the program randomly chooses between those based off a proportion of how well how well the best program did compared to how well the second best program did. So if one has a score of 100 and the second best program has a score of 80, then the first best program will have a more likely the traits of the best program will be more likely to prevail in the the next generation. But if the best program's score is significantly larger than the second program, then the best program's traits will completely dominate the next generation. But only having the traits of past generations limits the program to the maximum potential of those sets of traits, when in evolution we see that with time, new traits that have never been seen before arise. That's similar to how eventually fish grew legs and walked out of the water. These are called mutations. So just like that, this program has a random chance to apply a completely random decision to the program. And this random chance isn't too rare. It's not the most it's about a 20% chance of having a random trait replace the current trait. But those random traits are what help the program to grow and learn to accomplish the task better. I see someone's trying to ask a question. Go for it. I know there's a slight delay on the timing here. Okay, that's a good question. So what happens is the blue dots begin off screen at the bottom and only come up onto the screen if the current program tells the blue dots to go up in the start, in the starting situation. So in most of the cases in the beginning, the programs are not smart enough to realize that they need to go up in order to stop the ball. But as the program learns, you will see that almost all of the programs figure out that they need to go up. I know this because the current program that's being shown, I've already run to its extent, but I wanted an example to show the live stream. So basically, to explain that, is that the decisions set by the current program, in the ones that you don't see the blue dots appear, are very primitive decisions, because this is only the second generation. You can see up in the top left corner of the black box there, and that means that there has only been 2 generations of evolution to learn the task at hand. So back to what I was explaining. Um, so basically, the program goes through and it checks to see it sees if the general program does better than the past programs. So it saves the best program and the second best program, and then uses those as a meter stick for what a good program looks like in the next generation. If a program from the next generation does better than the current program, then in a strictly genetic artificial intelligence, that lists of traits will replace the current best list of traits as the new best list of traits, and the old best will become the new second best. And like I said, that is only in a strict genetic artificial intelligence, and I will explain the difference between that and what is going on now in a little bit. So basically what happens is what I have going on here is every time it starts running, like it is right now, the program runs each program a couple times just to check whether or not just to avoid the program getting lucky and catching the ball for no reason. Sometimes the string of dots will simply just flatten out and go straight up, and if the red ball were to drop right on the middle, then it would receive a very decent score, but the intelligence behind it is not that high. So I have it run it, I believe, 3 times when it's initially testing it, and it averages the score that it achieves through all of that. So what is different about the current AI I have running from a strictly genetic AI is that this one is a little bit smarter in my eyes. So what it does is, instead of looking at just the score of the programs in the next generation, when the program sees a child program from the next generation that has a higher score than the current best program, the artificial intelligence takes the new program and it scans through all of the traits and compares it side by side with the current best program. So let's just say the traits were blonde hair, blue eyes, and I don't know, just tall. So let's say the child program was blonde hair, blue eyes, and short. Then it would flag the trait for short and say, hey, this is different. Then it would take the trait that is different and place it into the best program in the place of the old trait, and test to see if the best program, simply with that one changed trait, is better than the current best program. If that is true, it replaces the trait, and instead of replacing the entire best program, moves on with just the one trait difference. And it does this for every difference that the program sees. Now, this causes it to run a little bit slower, simply because there's a lot more processing to be done. But the overall speed of learning and the overall rate of the score going up is significantly higher. Although you will see, and I doubt in the time that I'm streaming it will get to this situation, but there is a situation where the program will be stuck, because the way that an optimization program works is it's easy to think of it as like a topographical map. So just imagine a map that is showing all of the different elevations of a plot of land. So basically, the program itself is trying to work its way up to the highest elevation. And so basically, one would think that the best solution would be for the program to look immediately around it and say and find which direction will make it go up. And if it makes it go up, then it'll go in that direction, and it'll keep going in that direction, as assuming that there is not a better direction that it sees, until it reaches a point where if it goes any further it starts going down. Now this is a peak, so you can imagine this as, like, say there's a hill and you get to the top, you're at the top, any direction you go it goes down. Well, it could be very possible that there is another hill that is 10 feet to the right, and that hill is slightly higher. Well, if you're standing on the smaller hill, then you're not at the highest elevation you can get to. So that is exactly what happens in the program. It will slowly optimize the traits it has, adding in new traits as it sees fit, and it will get to a point where any changes relatively close to the current program are simply they just make the program worse. And the problem is that the program it reaches may not be the best solution for the task at hand, but the AI cannot figure out any way to improve the program from the current situation. So what my AI does is, if it reaches this point and it is stuck there, as you can see the number under stuck is 0 right now, because it just changed going into the second generation. If the number there stuck gets up to 50, which means after 50 generations it doesn't change, then this will sound morbid, but it kills one of the parents. So basically it says these two parent programs have reached the best situation they can, and that best situation is the best score. So that's that best score that just went off the screen. So then if it deletes the second best program and completely wipes the slate, it will keep a good basis, which is that best score, for continuing the learning process, but it drops it back down the hill a little bit. So what that does is it allows the program to possibly take a different direction, and therefore maybe it can head over to that other hill that's slightly taller. And then there's also another aspect that I've added in here, and I'm going to try and I'll try to explain that. So in addition to this to this extreme situation where it's stuck for a long period of time, um, I have added a different way of thinking for the artificial intelligence. So basically, what it will do is, if the artificial intelligence is stuck, let's say for 25 generations, um, then obviously it's still a significant amount of time. So as the number for stuck goes up, the probability of having a random mutation instead of taking the general trait from one of the parent programs goes up. So in order to do so, basically what happens is that 20% I was talking about earlier starts to become 30%, then it starts to become 40%, and this is what I like to call desperation. So basically it's saying, hey, if I don't start trying something new, then one of us is gonna die. So you can think about it in terms of maybe what the UCF football team should have been doing. It should have been trying something new because they were dwindling. But that aside, you can. So basically, what happens is, if you imagine your scenario where you're on the hill, you can imagine a small ring around yourself, and inside that ring is what options you have. So let's say arms without, and you spin around and you say, okay, what direction in terms of what spot in that circle is the highest spot, and you'll find that spot and you'll go to that spot, and then you'll check your circle again. Well, what you can do is if you can't find a higher spot within your circle, then you can look in a bigger circle. So just imagine the ring slowly getting bigger and bigger and bigger, and hey, maybe that ring bumps into that hill that is next to the smaller hill. Well, what the AI can do there is, if that higher if that higher potential is within the observational circle of possibility for the mutation traits, then the program can simply, instead of going down the hill and back up the new hill, jump from one hill to the other. This saves a lot of time, and it also allows the program to flow more consistently in an upwards direction. So in this time that I'm talking, it will be hard to see the overall effect of the program, but I'm hoping that over the course of this channel, I will be able to express this picture more clearly. But for now, I'm simply introducing the program. So I guess now I will put it to any questions any people have. So I'll just stick around. If you guys have any questions, just post them in the chat, and I'll answer them as I see them. I know there's it's about 13 seconds on the delay, so I'll wait and see what you guys have to say. Oh, that one actually looks kind of smart. If you can see that, it's making a U shape, but then it spreads out and does the thing I was talking about earlier, where it just sort of lays out there. And yes, Cubby, that is what I was explaining earlier. But yeah, so basically the blue dots don't really have any dynamic decisions. Maybe they only have a decision for one situation, or maybe those decisions that it does take don't really help the program. So what happens is the blue dots do not come onto the screen because they are not in a situation where they are following the red dot that is falling. I have a question about where I plan to go with this artificial intelligence. For right now, I'm just planning to slowly make the tasks it can complete more complex, so that it may be applied to a robotics situation. I have looked into some situations where this might be applicable, but at the current state, the program is a little sloppy, in the sense that it's not the cleanest in the code. So what happens is a lot of time and effort is lost in processes that really don't need to be happening. So as I clean the program up and get it to run faster, I'll be able to apply more dynamic situations. I did have a project I was attempting to work on where the program was simply given like 100 different variables to sort through and apply, and I found that it was very slow at finding the variables that were important to the situation. But in terms of long run, I would like to get into some more significant artificial intelligence applications. I don't know that this would be a commercial product. I think that this would be more of a I'm considering that it could be a sort of open source thing where, yes, I'm the one working on it, but it will be open for others to apply it to their situations. But at the current state, the program is not really in a manner to where it could be, let's say, legible to other computer programmers. I'd need to, if you know anything about computer programming, you know what a nightmare it is when something isn't properly commented and it's not your work. But no, this I do plan to make this a much more complex intelligence, and to hopefully find applications. And yes, Cubby, the ultimate purpose is for robots to take over the world and to destroy all humans, or at least make us obsolete, of course. But that aside, yeah, I basically want to make this something. My total goal is to try and make something that's new, and as of right now, the idea of a genetic program is not necessarily something that's hasn't been done before. It's just I think that the angle I'm taking on it from a microprocessing scale is a little bit different, but that may be that I'm taking some shortcuts that that have already been figured out. But no, yeah, I basically I want to keep improving this, and I haven't really figured out a end goal. I'm not really trying to set any necessarily, because I really don't know how to what I plan to do with it, but I want to leave it open to the realm of possibility. As you can see, in terms of it not being clean, it keeps conking out here, but that's not a significant problem. It just needs to be restarted every once in a while. But so does every computer and computer application. If you leave it running too long, mine just tends to have a shorter lifespan. But I have it set to where it can pick up where it left off, so it's not a problem. So, are there any more questions? Oh yes, that is a beautiful penguin. Thank you. Sorry if you're viewing this after the stream, you won't be able to see the amazing stream comments. If you're just tuning in, I have explained what is going on. I have explained the general idea of the program, but I'll give a quick rundown. Basically, what's happening is this program is learning to optimize its decisions for a specific task. You can't see the task at the moment because it's doing the processing part of it, but it will be up there in a few minutes. But basically what's happening is in this stage of the program is that as you can see all these numbers, there's 32 different child programs every generation. So basically what happens is it goes through, and each time you see a number, that is the child program it is working on right now. So it's looking through that child program. It's trying to see if there are any differences in that child program from the parent program, and if the child program has scored higher than the parent programs. But you will see it skip through a couple numbers like it just did there. That means that the ones it skipped over have not scored higher than the best program. So it simply just does not test, because why would it want a worse option? The only ones that are tested are ones that score even 1 point higher than the current best program. But it does take its time on the ones that do score higher, because, like I said earlier, it's going through and it's checking every single trait, every single difference, and seeing if that difference does better. Now, what's happening on a micro scale is the program is actually running the little simulation that you will see over on the side and have seen, but the thing is that it is not limited by the visual aspect of it. So in this stage, it's not something that needs to be viewed, so it just runs that aspect of the program as fast as it can, and you'll be seeing that that visualization popping up over to the right here. There we go. So this visualization is not something that is necessary, but it is nice to see what is going on. So basically what happens is it runs this program where the ball falls and it does the decisions that the traits tell it to, but at a very high rate, with only doing things based off of the variables that are associated with these different images. So in that time where the numbers are ticking by, it's maybe doing this at probably 100 times the speed. That could be an exaggeration, but I have a question over here. It says that when it freezes, that just means that it is done testing the different programs. So you'll see up in the top left corner, it says that program and then a number is going up. I said there are 32 child programs, so when it hits 32, it stops testing them, and it then goes into the process of checking the ones that scored higher for to see if they are actually better than the parent programs. So what you'll see is now how it is frozen. It's going into the stage where where it's scanning through and checking all of the different traits to see if there is a difference with those between those programs and the parent programs. And like I said before, it is replacing those traits that are different with the parent program's traits to see if the parent program would benefit from a change in that trait. Now there is an overarching situation. So in the start, the programs tend to only have maybe one decision, or just one decision that they're making. If some of the early generation programs get lucky, they will make a couple decisions, but there is a variable, and there's a trait per se that is how many decisions the program makes, and as those programs get lucky and randomly choose to have more decisions, if having more decisions, which ultimately would make the intelligence more dynamic, would improve the score, which hopefully it does. It usually does, but like I said, everything, or like I might not have explained perfectly, everything that all the changes are random, and basically what happens is it tries a bunch of random different things, and I reward it, or the program itself rewards the situations that do better. So basically what that does is it takes the randomness and applies a force to it to push the average score of the programs higher and higher. And that's may seem a little hard to picture, but It's somewhat like training a dog, for say. If the dog does something good, then it's like training a dog without the negative reinforcement. So if the dog does something good, then you give it a treat. You associate that situation where it does something well with a with gaining something, with gaining a new reward, or with something it should repeat. And if the dog does something bad, then you don't give it a treat, so it doesn't. It may try that again, but it won't remember and say, hey, I want to try that again. It will just randomly occur. So it's in that sense, the program trains itself to be better at the game. This is a game, but in applicational purposes, this could be applied to maybe a robot that is walking. Well, first you have to get it to stand up. So maybe you say that the fitness score is based off of how high it gets in the air. So it would try a bunch of different things, and as the new situations cause it to rise, it would it'd say, hey, that time I got a little bit higher, so what did I do that made me go high? What did I do that made the robot get slightly higher? So that's what's happening when it scans through. It goes and it checks and says, okay, did this make the robot get higher up in the air? Did this make the robot get higher up in the air? And then it says, hey, this did make the robot get higher in the air. So it flags that, and it adds it and incorporates it into the parent program, so that trait can propagate into the next generation. So are there any more questions on the AI here? Or any more questions on the channel? I can talk a little bit about what I plan to do with the channel here. I know I explained it a little bit in the first video, but it wasn't the best explanation, and it was a little choppy. By the way, if you read the description on that video, I was a little more clear on my goals for this channel. Just because I was able to think it out. I really want to try and put up, at least for the live streamed videos or the full live streams, I'm just going with the raw ideas and the raw, like, whatever I say is going up on the internet, assuming I don't accidentally say something extremely offensive, which that's not really the kind of person I am. But what I plan to do is, basically what I'm going to do is, YouTube already has it set up so that all of the live streams are automatically processed and uploaded to the channel. So I will leave the total video. I will leave the total video up as for anyone that maybe missed the live stream and wants to watch the whole thing. I'm adding a playlist that has the full live streams, but then I'm also going to add, I'm going to go through, and if there is a significant event, maybe something significant happens with the AI, or maybe I sit down and explain something like I am right now, I'm going to cut those clips and upload them separately, so that maybe if you don't have time to sit down and watch the whole live stream, you can still get the highlights and the important information. um, from those videos. So that's basically the outline of the channel. But what I plan to do is once I get a little bit of an audience going, which I'm happy to see that there's a couple people watching. I'm going to start to transform this into a little bit of a talk show where while the AI is running, I will talk about the AI as it goes in the background, but I will also be taking questions and talking about other topics not specific to artificial intelligence, so that I can chat with the audience and sort of pass the time, because you'll find that it may be interesting right now, not really knowing what's going on in the background and seeing these blue dots come up and chase this red ball, but when it comes to really running the program for a long period of time, it can get a little monotonous. So I'm just gonna hopefully just be able to come on and chat with you guys, and well, basically what happens is I want to force myself to learn new ideas, and if I come on and try to explain them to people, that will force me to research the topics myself, and will allow the people of the internet to check my information on that, so that I can learn from the situation as well as the people watching. So that being said, I'm planning to keep this relatively professional, but knowing me and knowing if I bring any guests on, it could get a little out of hand, but we'll see how that goes. I'm not really setting any specific goals, because I want to just allow this channel to evolve, much like the program is here. I want it to evolve and just become whatever is natural for me, and whatever seems to help the general knowledge of the people around and people watching the stream grow. So I hope that gives a good explanation of what I'm planning to do here, and I'll take any more questions if you guys have any more. But I do think that around 9 o'clock I am going to sign off here. But I'm actually surprised. I'm glad I could actually sit here and talk for an hour, so that's a good sign. I'm going to have to get some more material to talk about for future streams. So I don't know if this will be a weekly or this is definitely not going to be a daily event, just considering my my scheduling situation. I don't think that there will be a set time or a set day that I'll be streaming. It'll basically be off of when how much I work on the actual AI, and when I feel comfortable and when I actually have time. I am kind of limited on what I can do, and in terms of like when I can stream. I don't want to disturb anybody else in the household here, but I'll definitely be posting on my Twitter page if I'm streaming, and for the beginning few times here, uh, I'll be advertising on my personal Twitter and Facebook page like I have, just to get the word out. But as the channel grows, I will be moving to the Twitter page, considering that it'll be easier to just put it in one spot and go from there. But if you have a Twitter and you want to support me, there's a link to the Twitter page on my About page, and you can simply click on that, or I believe it's just Jono Explains. I don't think it's Jono Explains Things on Twitter, but it'd be great if you guys could subscribe or follow me on Twitter, so that you can know when the next stream is. I'll be spreading the word, but if you guys know anybody that might be interested in this artificial intelligence topic or ideas, or if you know anybody that simply might be interested in listening to me talk or anything, just give them a shout, because I'm really trying to start up this channel. So with that being said, I'm not seeing any more questions, so I'm just going to sign off here in a second. We'll see this last generation here and see how it does. And it looks like it's still not doing too well. So what'll probably happen is, with the current program and how it's set up, I'll save the current generations, and I'll start streaming from where it's at right now, so you guys will be able to see over the course of mini streams how the program evolves. So yeah, I'll let this last generation ride out, and then I'll say goodbye right now. So thank you guys for coming on and watching, and I will inform you of the next streams in the future.